Hey, welcome back. All right, sediment can be deposited, and what we're looking at now, whether it's sediment layers or sedimentary rock layers, helps us to infer the depositional environments of the past. So there's a few different depositional environments. This one will focus on continental or land depositional environments. So a depositional environment is anywhere sediment builds up, accumulates, um, especially in a particular area where you start to see distinctive kinds of deposits from specific physical, chemical, or biological processes. There's three broad areas of deposition. You have continental deposition, you have marine deposition, ocean, and then kind of in between. That's called transitional. Each of these has kind of specific sub-environments to them. So when we're talking about deposition on continental areas, that's this area, and that can include some sub kind of areas like stream environments or glacial environments, lake deposits, sand dunes, alluvial fans, which we'll get to. Transitional environments between land and the ocean, kind of in between there. Um, Tidal areas and deltas and barrier islands and lagoons. And then marine environments, kind of shallows of the ocean, deep waters of the ocean, and what we have there. So each of the next three sections will be dedicated to each of these environments. What do we see in rocks that help us infer that the sediment that was deposited to make those rocks came from one of these three environments? But again, let's focus on continental environments. This is a deposition of sediment on continents or on land, and that might take place in fluvial systems, which are streams. It might take place in deserts or areas covered by and or adjacent to, next to glaciers. Each of these different environments has combinations of features that allows us to attribute deposition to kind of one of these things, so there's ways to differentiate them all. So let's talk about fluvial systems. So fluvial refers to stream activity and to their deposits. Fluvial deposits accumulate in either two types of systems. Braided stream system. So we're talking about streams. Streams are any flowing water, rivers, creeks, brooks, those sorts of things. So we have braided streams. Braided streams have kind of multiple broad but shallow channels in which bigger sediments, usually gravel and some cross-bedded sand, are deposited. There's almost no mud, so no smaller size particles. We'll look at pictures of these here in a second. But then meandering stream systems, these are typical single winding channels. You start to get into the more fine-grained sediments, especially on the floodplains, which are the areas, adjacent to the river that could flood. Whoa. You do get some cross-bedded sand bodies with some of that shoestring geometry that we saw in the previous section. And you also get something called point bar deposits, consisting of overlaying sand and an erosional surface that happens kind of in the outer, or the inner point of the meander loop. We'll look at all this, all right? So here's a braided stream. It's almost like, think of braiding hair, right? It's a bunch of channels intertwined. Right? A bunch of channels intertwined. So again, you usually see bigger sediment, so sand and gravel, which if lithified turns to sandstone and conglomerate. So in a stratigraphic column like this might indicate a moving braided stream system was in the area. And this is a meandering stream system. It kind of, one single big channel meanders about. These lighter areas are kind of builds up of sediment, mostly sand, and those are the point bars, and they're on the insides of these meander curves. So, depending on what you see, so maybe more finer grained sediment to eventually create sedimentary rocks, maybe some point bar deposit, depositions within the geologic column. So this area, this is indicating now meandering stream systems, this fluvial environment. Deserts are another area of deposition. Desert environments contain an association to features like sand dunes, go figure, things called alluvial fans, and playa lakes. By the way, sand dunes, not every desert has a sand dune. I know in the movies, when they're talking about deserts, they have sand dunes. Think about Phoenix. We're in a desert. How many sand dunes are around Phoenix? The answer is 0. So anyway, that's just kind of a side note. Just because it's a desert doesn't mean it has to have sand dunes, but if in the geologic record we're seeing evidence of sand dunes, that could indicate desert environment. Because there are some there are many deserts that have sand dunes. The Sahara Desert, for example. So anyway, speaking of dunes, let's focus on that for just a second. So these wind-blown dunes are typically composed of well-sorted, same size, well-rounded sand. They kind of get blown, all these little particles of sediment get blown together, so they kind of round off. We can get some cross-bedding, which we saw previously. And we might also have plant fossils, animals, as in animal tracks, oftentimes in these type of rocks as we're trying to analyze them. So what we see now, right, sand dunes, but after time, a little bit of heat, a little bit of pressure, the lithification process sticks all that together. When we're looking at kind of geologic columns, and we see this sort of pattern, this is cross-bedding again, and we can indicate which direction the prevailing wind was that created these sand dunes before they lithified, before they turned to stone. Adding on to deserts, alluvial fans and playa lakes. Alluvial fans form along the edges of desert basins where the basin itself kind of butts up against some mountains. And let's say you have some rain or some melting snow. As that material comes out of the mountain onto the flat plain at the base of these mountains, it deposits sediment in a fan-shaped, kind of this triangular fan-shaped thing we call an alluvial fan. And usually it's sand and gravel, higher energy transportation with this flowing water. And the more central part of a desert basin, as you get away from the mountains, away from the alluvial fans, which we'll look at here in a second, might be a site of a temporary lake, usually called a playa lake, in which itself may get some sediment in there. And it's usually a very shallow, very low energy environment, so you can get, mud and clay-sized particles depositing, so you can get laminated mud, as well as evaporates forming in these playa lakes environments, because the water will eventually evaporate away. So here's what an alluvial fan looks like kind of from the ground. You can imagine if it rains in this area, sediment, sand and gravel size is kind of coming out of the mountains and deposited. From above, it has kind of a fan shape, hence alluvial fan. And then beyond the alluvial fan, in the flat parts of the desert, that's where a playa could form, where you get this gentler, lower energy environment where clay and mud-sized particles, silt, can deposit. So we're forming different types of layers there. So that's what we can see. So all of that is indication of desert environments. Glacial environments, all sediment is deposited in glacial environments. We call it all drift, glacial drift. It's due to glacial movement. Type of drift called till. Till is very poorly sorted, big and small pieces. They're usually not layered or stratified. It's usually like a big hill clump of it. And that's deposited directly by glacial ice, mostly at ridges at the end or edges of glaciers called moraines. Glacial outwash is a type of till where it's sand and gravel, usually moved from glacial meltwater, kind of creating these braided streams issuing from melting glaciers. All that gravel is called glacial outwash. Also, some other structures we might see some scratches, these striations, these scratches in the underlying bedrock, which also indicates moving glaciers, large slabs of ice moving over rocks, and they just scratch into them. So that's yet another feature. So we have some very poorly sorted till. So you can imagine a glacier, again, as it's moving, glaciers move. At the end is where they melt, and they deposit any sediment they pick up along the way to form these big ridges at the end called moraines. But, they also melt internally, bringing with them sediment as well, usually very poorly sorted sand and gravel, and to help in aid creating an outwash plain and braided streams. Oops. So braided streams are usually streams that have a lot of sediment in it, and not always, but they can be very much associated with melting glaciers because glaciers have a lot of sediment. They break down a lot of rock as they move through and carve through mountains. So any meltwater or whatever they push at the end is going to have a lot of sediment in it. And when you have a lot of sediment in a flowing river area, it has to find ways to get through that. One more little kind of subsystem with glaciers are glacial varves. It's a fun one. They're glacial lake deposits showing alternating dark and light laminations, the thin layers, very thin bedding. Each dark and light couplet is kind of it's paired together, and it represents 1 year of accumulated sediment. The lighter layer is accumulated in the spring or summer when glaciers are more apt to melt. It's warmer, so you get more melting ice. That water brings with it silt and sand, so it gets deposited because you're kind of moving more of that material off the mountain into this little glacial lake. But the dark layers indicate winter depositions. If this lake is up high in an area with glaciers, the surface is probably going to freeze over in the winter. So you're not going to be adding any more sediment. So that allows for any of the suspended sediment and any of the very small clay-sized particles that were just kind of in the water to finally settle down to the bottom, forming a darker layer. So the light and dark layer is a couplet and kind of goes together. What you might also find embedded in these varves, What you might also find embedded in these varves are these kind of bigger stones. These are called drop stones, and these are usually liberated from icebergs that may be present. Maybe a piece of that glacier fell off into the lake, and it's a little floating iceberg. Might have a big rock in it. Over time, as that iceberg, gets smaller and smaller, maybe there's a big rock and it just kind of falls out of it and sinks to the bottom of the lake, and that's what creates these big rocks and these varves. So here's an example of a glacial lake right at the foot of a massive glacier. Not sure where this is. But you can imagine, during spring and summer, melting water brings all this sediment with it. Deposited in here, that sand and silt will deposit at the bottom. When it freezes over in the winter, it allows for any smaller particles that are suspended in that water to filter out or settle out. So here's what you see. So here's that lighter and darker. So that represents 1 year. Summer deposition, winter deposition. Oh, there you go. So let's go ahead and pause here. So that was how rocks can help you infer continental depositional environments. So we'll pause here. When we come back, we'll look at that transitional depositional environments between the continent and the ocean, kind of right at that boundary between the two. I'll see you back here in just a second.